Roger Pielke, thanks for joining us. You're very welcome. Could you first, as a start, summarize for me your thoughts about extreme weather events and climate change?
Yeah, the category of extreme weather is a big bin, and I find it useful to break it down into specific phenomena and sometimes specific phenomena in specific places. Um, Recently, a few weeks ago, I testified before the U.S. Senate on this topic, and there I presented data that showed that specifically in the United States, but also globally, there are no upwards trends in the number of tropical cyclones, of which hurricanes are a subset, drought in the United States or globally, uh, floods, again in the United States or globally, or tornadoes. There is some data that suggests there's been a greater incidence of heat waves over the last 30 years in particular. And then there's also a category that's called extreme precipitation, for which there have been trends documented, but you have to be very careful because extreme precipitation is not the same thing as flooding. Uh, there's a lot of reasons why, but one reason is that what scientists define as extreme often is not at a threshold that leads to high stream flow.
So, your view that there is no evidence for an increase in hurricanes, in cyclones, and that is that a consensus view? How much debate is there about this?
Yeah, well, actually, the science of extreme events and trends is among the least complicated you'll find in climate science because phenomena like hurricanes are big. You don't miss them when they occur, and they're rare events, so there's not a lot to count. And the fact that there is not an increase in hurricanes or tornadoes or floods or drought is not really controversial in the scientific community. In fact, the IPCC, Intergovernmental Panel on Climate Change, concluded the exact same thing in its 2012 special report on extreme events. So this is not an area where you're going to find a lot of controversy over the data. And in fact, some good evidence for it is I gave my widely publicized congressional testimony 2 weeks ago, and the blogosphere and the Twitterverse, which usually jump on anybody who makes a claim, was oddly silent in responding to my testimony. So I think the data holds up extremely well.
And yet, in the media, we hear a lot about the link between supposedly an increase in extreme weather events and the effects of climate change.
Yeah, you'll see politicians, campaigners, and some in the media echoing claims that we are in what's been phrased a new normal. The idea that we're in an era of greater frequency or intensity of extreme weather events. And that's just not the case. In the climate debate, as people who pay attention know, there's all sorts of hyperbole that goes on all sides. And extreme weather happens to be the latest hook that campaigners for action have tried to hang the case for action on. And in my view, it's a misstep because the data just doesn't support it.
At your testimony, Professor Jennifer Francis said that you were missing out on the extremes because you were looking at too wide an area. You were averaging it out by looking globally and across the whole United States, and that you had to be more regional to see these extreme weather events. How do you respond to her views on that?
I think you go down a slippery slope if you want to claim that every bad thing that happens in a particular location can be attributed to greenhouse gas emissions. You can make that argument, of course, put forward a hypothesis, but you have to support it with data. And the IPCC for many years has looked at broad regional and global trends. And the most obvious example is the global temperature record, which is an aggregation. For many years, people on the skeptical side who would say, well, look, it's cooling in Timbuktu would be argued down and say, you can't look at one data point and come up with broad climate trends. And it's the same with hurricanes, drought, floods. The data simply says that globally there has not been an increase in these phenomena. And anyone who wants to make a case that climate change caused by humans is causing an increase in floods in Massachusetts, for instance, has to support that with evidence, theory, and data.
So regional is natural variations, and to actually see a trend, you need a much larger set of data.
Yeah, well, there is enormous variability in the system, and the more finely you cut it in terms of space and time, the more difficult it's going to be to identify significant trends, but also to attribute them to particular forcings, which is one reason why climate, by definition, is an aggregation of statistics over time and space.
Where are we at in attributing events like the Russian heat wave or the drought in the United States and the Midwest in the last few years? Where are we in the science of attributing those to climate change?
Historically, the IPCC proceeded with a two-step process. The first step was the detection of a trend. So to identify a trend in a statistic of climate that occurs over what the IPCC says is a period of 30 to 50 years or longer, so many decades. Once you've detected a trend, the second step in that is to attribute it, to explain, well, why is that trend actually occurring? For extreme events, looking globally or regionally, the detection step hasn't even been achieved. So there's little question in attributing because there's nothing to attribute there. Now, more recently, there's been an area of research that's opened up focused on specific event attribution, which is really an exercise in modeling to ask, can our models explain the evolution of a particular event without the addition of greenhouse gases, for instance? Those sorts of studies are very much in their infancy. They're probabilistic. I think they're great exercises for expanding how we think about these issues. I wouldn't put too much weight on them, for instance, to have specific claims of attribution. There was a recent study several years ago, I believe it was published in Nature, that looked at the UK and looked at several floods. And it's an interesting exercise, but the region in which they focused has not seen an increase in flooding overall. And the model that they used wasn't initialized using soil moisture, which is a key factor in flooding. So I think these sorts of partial attribution efforts are interesting scientific hypotheses, but they're not quite at the level where you would put a lot of weight on them.
President Obama, in his State of the Union speech, said something like, I know one event doesn't make a trend, but he said the judgment of science was clear on extreme weather events. How do you, having looked at the data, how do you react to politicians making such bold statements?
Well, politicians say all sorts of things, and it's not just climate change. And on that instance, President Obama was simply incorrect. I think, my view is fairly laid back in terms of politicians saying things. I think it's something altogether different when experts or even campaigners who are arguing on the authority of science say things that are misleading or incorrect. More troubling than President Obama kind of getting forward on his skis with his extreme event statement is the absolute and complete silence among my colleagues in the scientific community, who are normally quite quick to correct or amend or clarify statements that are made in this debate. It seems that there's a double standard here, that if President Obama says something that's incorrect, he gets a free pass. But if, say, Senator James Inhofe says something that's incorrect, he gets roundly criticized. This contributes, I think, to the perception that the scientific community is not always fairly arbitrating the science in public debates.
Because if you looked at the media, if you looked at media reports of heat waves, of flash fires, of floods, of hurricanes, of what's been called Hurricane Sandy at the presentation you were at in front of the US government a few weeks ago. If you look at the media, you would think that there was a consensus that this is happening.
Yeah, I'd like to see a study of media coverage of extreme events. I have this sense also that it's not always so accurate. With several colleagues here, we did a study of the media coverage of sea level rise, and we found that it was quite accurate. I don't think that would hold up for extreme events. There are a number of my colleagues in the scientific community who are willing to go out on a limb and say things about attribution with extreme events and so on. And I think, my view is that extreme events and climate change is somewhere in the same media space as, shark attacks and things like that are sensationalized and really are entertainment stories and don't have a lot of scientific value to them.
How do you gather the data for this? How much data are you going to need to evaluate what's happening and to notice if there is any change occurring in the future?
Yeah, so the scientific community, and by that I mean, the mainstream IPCC reports, project that there will be more frequent and more intense extreme events in the future. We did a study, it was led by Ryan Crompton at Macquarie University in Sydney, where we took recent climate model projections for changes in intense hurricanes. There was something like an 80 to 90% increase in the incidence of Category 5 and Category 4 hurricanes in the United States by 2080, something like a 1% change per year. So we took that as basically the truth. And we said, let's assume the world evolves in this way. When would we be able to detect that change in we were interested in the statistics of damage, but you could also ask, when would you see that in the statistics of hurricanes? And it turns out, starting with that assumption of these very large changes, it's going to be many decades, maybe centuries, before we actually can detect, according to the IPCC definition of detection, a change in the statistics of these events. The main reason for this is that they are extreme events. They're rare. They don't happen a lot. So it's a little bit like playing poker and someone puts another ace into the deck. You have to play an awful lot of hands before you have some sense that the deck has been stacked. What that means is that there's actually no scientific reason to expect, this is with respect to hurricanes, that we would be able to detect a signal today, even assuming the effects that are projected going forward. To the extent that the statistics of other extreme events like floods and drought are similar to hurricanes, you're going to get very similar results. So the long story short is that we really shouldn't expect to see these signals for many decades going forward.
So I won't mention any names, but what would you say to the many scientists who appear in the media with quite categorical statements that we have a new normal, that the extreme events that have happened are part of a new regime of climate for us, and that's down to man-made climate change?
Well, I would divide the expert community into two parts. As individuals, all of us have to take responsibility for the statements that we make, and it's perfectly legitimate for people to hold outlier, minority, or even wrong views in the scientific community. I don't see any problem with that. Where I think more vigilance is needed is with respect to the institutions which represent themselves as speaking on behalf of the scientific community or on behalf of legitimacy more generally. So specifically, I'm thinking the Royal Society, the National Academy of Sciences, the IPCC. These organizations and the people who speak for them have an obligation to play it straight, to express what the science says, recognizing that there are minority viewpoints, there are uncertainties, but the credibility of these institutions is risked when people go out and say things that are demonstrably incorrect. We've seen that, in this debate, when institutions go forward and try to represent the science in a way that just doesn't stand up, they do take a hit. And the IPCC, Glacier Gate controversy is an example of trying to maintain something as true, which is demonstrably not true, is not a tenable position. Why
do they do that? I mean, these are eminent, clever people. They're scientists of high standing. What are they doing? Are they trying to make the message too political, too simple? Why do they say such things which you maintain are just not backed up by the facts?
Well, the IPCC got itself into some trouble in the fourth assessment report. This is widely known in a number of areas, mainly in Working Group 2. And extreme events is one of the more egregious failings of that report. I'm not an insider. I don't know why. I mean, it is clear, and I've documented this, they included a misleading graph. They said some things that just weren't scientifically supportable. Was that because of campaigning? Was that because of pressure? Was that because of quality control? I have no idea. What I do know is that in the special report on extreme events by 2012, the IPCC had gotten its act together on this particular topic. And from my perspective, as someone who studied this topic for 20 years, I think the SREX, as it's called, got it right. And so the IPCC reflected a healthy evolution, at least from 2007 to 2012. Now, whether that sticks or not in the next report remains to be seen, and people will be paying attention. But that's one of the good things about empirical science, that over the long term, good arguments will win out over bad arguments. That may not be comfort to people who are campaigning and would like to see the good arguments win out in the short term. But one of the strengths of science is that over the long term, the good arguments will win out. So I'm fairly confident that on extreme events and disasters, even with the froth and the excitement and politician, campaigner, media misrepresentations, the data is pretty strong, and just stick around. It'll win out.
So why is it that people have latched onto extreme events in the way they have? Do you have any thoughts as to why it has become almost the flavor of this year to talk about extreme events increasing in frequency, increasing in intensity, and that we're to blame?
Yeah, well, I think it's pretty straightforward and not a secret. It's that campaigners for action on climate change have decided in the last several years that a way forward on this debate was to focus on the things that have meaning to people in their immediate context. And extreme weather, which would seem to have a relationship to broader climate change, is the hook that's been chosen. Extreme weather has always really been part of the debate, at least for the last 20, 25 years. But there's been a much more explicit effort to try to connect Hurricane Sandy or Katrina or the drought of the U.S. or the hot summer in Europe, or pick your event and say this is the sort of event we expect. And there's some clever language that goes along with that. Sometimes people say this is consistent with what we would expect, which is a meaningless statement, or they say this is the sort of event we will have more of in the future, or they go even further out on a limb and say this event was caused, influenced, impacted in some way by greenhouse gas emissions. It's a very slippery slope to go down when the data is against you. And I'm not sure how long this particular approach will be in the debate, because I don't think it's sustainable, but it's with us now and a lot of attention is being paid to it.
I read some very interesting statements about the Russian heatwave, which said that it was within natural variability, but it was made more likely by human-induced climate change. How do you respond to comments such as that it's natural, but it's not natural?
Well, again, this gets back to the event and partial attribution studies. And you see many such studies related to what's been called Hurricane Sandy, although whether it was a hurricane or not at landfall is contested. I think those studies are interesting. There has been a debate, I think a healthy scientific debate on the Russian heat wave that involves some of my colleagues here at NOAA, some other folks. But really, if you are interested in the societal response, the cost of these events, what really matters are the trends in the incidence and intensity of those events over time. So if you say an event happened on Tuesday rather than Thursday because of greenhouse gas emissions, that may be interesting scientifically, but if your job is to deal with the cost of an event over a year, what you care about is the absolute magnitude of those costs and their overall frequency and intensity.
As a scientist interested in extreme events, who's studied them, as you said, for 20 years, do you feel any frustration that the message is not getting across?
Not so much. I think that, to be honest, I'm actually quite optimistic that the message is getting across. If you step outside kind of the media sphere of the climate debate, and really the public representations of the debate, and you talk to people who make decisions in coastal communities, in reinsurance companies, these folks have a pretty good sense of what the data says, because actually they have to make decisions based on the data. I think it's a very different world if you're dealing with the symbols of climate change and you're trying to affect a broader public discourse versus you're managing a portfolio and you have to lay off risk in the international capital markets. For the latter, you're going to make sure your numbers are correct, and you can't be in the business of shading things one way or another. So it's like many topics that become highly politicized. There is a kind of a cartoonish overlay, but the reality is that important decisions are being made by people who care about the data. And over the long term, the campaigners on climate change on both sides are going to have to figure out what's real and what's not real if they really care about taking effective action.
And that's the faith I think we both have in science, that eventually the data, the reality, will win through in the end.
Yeah, well, I think if you're going to engage in arguments that are grounded in empiricism and data, you kind of have to have that faith. Otherwise, you'd wake up and say, well, none of it actually matters. And in the short term, you can have those frustrations. But I've seen, great changes in this debate over the last 10 years when, the sort of congressional testimony that I gave 2 weeks ago would have been unacceptable in many respects. And now it's coming to be broadly accepted, especially in the scientific community and, again, among serious decision makers, that this is what the data says, and we're just going to have to deal with that and proceed from that basis.
Professor, it's been fascinating. Thank you very much. Is there anything you want to add or deal with that we haven't, that you feel we should?
No, I think it's been quite a wide-ranging and good discussion. I appreciate the opportunity to share some of these views.